Bismillah ar-Rahman ar-Rahim. Inshallah, today we are going to start with lecture 4, sensors and interface. Today we are going to introduce as you know, that we have a physical system. That physical system has a physical phenomenon. This physical phenomenon is converted to uh, electrical signal using transducer sensor, and then after it is captured, we have to make signal conditioning, then analog to digital converter, then it reaches the computer. Today we will concentrate on this part, which is transducer and sensors. So today we are going to talk about digital input-output devices. We will see how digital sensors is used for capturing analog signals, and we will talk about transducers and sensors, and we will talk about very important circuit here, which is Weirstone bridges. They are used in sensors and transducers. We are going to see how or the idea behind Wheatstone bridge, and how it is going to be used in measuring the electrical signals. And we'll talk about two common sensors, thermocouples and resistance temperature devices. These two devices are used for temperature measurement. We will see how these sensors are used. We will see how they are working. So these are the contents of or the main topics of today's lectures, inshallah. So we'll start by introducing the sensors. We know that we have signals, we have analog signal, and we have digital signal. The analog signal is continuous. Continuous in time means there is no discrete, there is no values, or there is no space in time that doesn't have signal. But here it is discrete. Discrete means we have sharp transitions. We have sharp transitions. So, for example, at this time we have value high value, and then transform it to low value immediately, suddenly, and then from low value to high value also suddenly. As I always say, the difference between analog and digital is like when I'm telling you the temperature, your height. But when I tell you how many subjects you study, you cannot say one subject and a half. There is no one subject and a half. When I tell you how many child you have, you cannot say I have one child and a quarter, or I want 1.5 childs. There is no 1.5 childs. There is either one or two or three child or zero childs. So it's like that. So we have continuous, we have digital signals. We will deal with both of them actually, because um, it is like we cannot get rid of this phenomenon. We cannot get rid of dealing with both of them. Both of them are important. We will see that we can capture digital signal immediately from the physical sensor or the physical device, and we also can capture analog signal and then we convert it to digital after that. So both of them we have to deal with. But how the digital signals carry information, as you know, maybe um, it's all about information. How the information is transformed using the digital signals. So the digital signals has or have some parameters, and these parameters are used to carry information. For example, the frequency. We can put some information on the frequency. We can put on the duration, on or the duration of the signal. We can put it on duty cycle or absolute number of pulses. All of these can be used as a parameters for having information carried on this signal. But for the analog signals, here the most important thing that the amplitude cannot carry information. In digital signals, the amplitude, there is no amplitude. It's all about frequency, all about the duration of the signal, the duty cycles, and other parameters. But the amplitude of the signal doesn't carry information. But here in analog signal, the information is carried on the magnitude or the shape of the signal or the variation over time. Okay, so most of real world process are measured using analog signal. Again, we have digital signal, we have analog signal. Digital signal carry information in its frequency, in its duration, in its duty cycle, or the absolute number of pulses. These are the parameters that can be used to carry information on digital signal. But here in analog signals, it is different. We carry information on the magnitude or the shape of the signal or the transition of the signal over time. And most real world phenomenon is expressed in analog signal. So we have the uh, DA and C, data acquisition and control. We have two ways. The first way is to accept data from the analog world and then uh, convert it to digital, or the opposite, which is getting out data from the computer. This is like controlling or I mean sending signals to the actuators or lamps or relays. Some devices maybe we will need them like multiplexers and programmable gain amplifiers and analog to digital converter. Look at this shape, look at this figure. Concentrate on this figure is very important. We have four sensors here. The sensors has analog signal. The analog signal is conditioned here, so the noise is removed, and all of the four signals, all of the four sensors are chosen. One of them is chosen using multiplexer. So one of them will be active at a time, just using multiplexer. Then the output will be passed to the amplifier for possible amplification of the signal. And the signal is passed by a unit called sample and hold. This sample and hold is very important, like you're working like a buffer and then working like taking samples or sampling just to represent data, just another representative. You can say it is like a buffer holding the signal. Then the sampled signal is passed by the analog to digital converter, and the analog to digital converter pass the data to the PC. After the PC deal with the signal, it can initiate some control. The control is done in digital, so it should be converted to analog again using digital to analog converter, and then passed by a unit. That unit is called the analog signal conditioning. And finally, that signal is passed to the actuator for possible control of that actuator. This is the path of analog signal, either coming to the PC or getting out from the PC. What about the digital signal? Cannot we get data as digital signal immediately from the physical world? Yes, we can. We have some switches and we have some kind of devices like switches and relays. We get digital signal from it. There is no need for analog to digital converter. There is no need for hold and sample. There is no need for other devices, just digital signal, and the digital signal is passed directly to the computer. And then the computer also will initiate digital signal, and that digital signal is passed to the relays or actuators immediately without the need of digital to analog converter. So it's like maybe you always hear about the analog signal from the outside world, then analog to digital, then getting data out from the PC, then digital to analog, and so on. But also we can have immediately, you can take digital signal from the outside world. Okay. Any question in this part?
No, Doctor, clear, clear.
Any question about the element of analog to digital converter? Okay,
It's clear, Doctor, it's clear.
okay. Um, okay, I will just ask some questions. Okay, let me ask some questions for you. Oh, can you tell me, anybody can tell me the difference between analog and digital signals and give me some examples?
Doctor, the analog signal is continuous. The digital signal are discrete, Doctor.
The screen. Okay. Uh, I will give an example and you tell me if it is discrete or continuous or digital and an or analog. Okay. Um, anybody can answer, no problem. For example, uh, number of the number of subjects you study, digital or analog. It can be represented by digital or analog signal.
Digital, Doctor.
Digital doctor.
Yes. Okay. What about the temperature of your body?
Uh,
Continuous, Doctor.
Yeah, continuous. Yes, exactly.
Analog.
Yes. Okay. Another question for you. Can we capture digital signal from the outside world immediately without the need of analog to digital and digital to analog? Can we? I mean, we always get analog signal from the outside world and then convert it from digital to analog, or sorry, from analog to digital. Then the PC will deal with it. Then it can initiate some control signal using uh, digital to analog converter. Can we capture data immediately in digital format without the need of analog to digital and digital to analog? Can we or not? Elias Yahya is saying yes on the chat, but I need more explanation. Can we? Yes, exactly. Elias Yahya, you are right. We can do that using switches and relays. Okay, okay, let's continue. Thank you. Digital input output devices. Actually, we will study some devices that is very important in our digital input output devices, digital input output devices, like uh, TTL digital signals. TTL is an abbreviation of transistor logic, and TTL can work in a high speed. It also can be interfaced with the PC directly, but actually it has some drawbacks. The first drawback, it cannot lead or drive, uh, not drive Another, it cannot drive, or it has a limited capacity, and it can drive only low current devices. It cannot drive high current devices. This is its drawback. So it can drive another TTL or LEDs or transistors. It cannot use for driving high voltage devices. It cannot it cannot do that. This is the first drawback. It also ideal for communication or communicating with devices on plug-in data acquisition and control cards. It cannot used for long distance transmission. So TTL is like it has no big power. It is not too strong. It is fast but not strong. You can say that. TTL is fast but not too strong. So they use it on the chips on the motherboard, immediately used for interfacing devices on the motherboard, like extension slots or extension cards. It cannot used to drive long distance devices. It cannot be used to drive high voltage devices. Okay, so this is the TTL. And another device which is opto-isolated input output. Opto-isolators can provide isolation from high voltage like 500 voltage to even few thousand voltage, and also frequencies up to several hundred kilohertz. And I want you to see the figure immediately. To the left hand side, we have the opto-triac version, and to the right hand side, we have the opto transistor. The opto transistor that we know, I think you have seen this, you have seen this kind of circuits before. It's simple. We have a light here, and this light is another. I mean, the light is directed to a phototransistor, and this phototransistor, when there is a light here, this logic becomes one. There is no light here, this logic becomes zero. So it is directly affected by light. It's like, okay, we have high power here, low power here. There's no difference because only the needed to communicate between between these two circuits is light. So light will not affect the both of the circuits. Here we have another one which is used in the mains switching. To the left hand side, it's used in the mains switching. The mains switching is the high power switching, the high power, like the switches used in our home. So here we have we have seen the opto isolation in two different devices. The mechanical relays and switches. The mechanical relays and switches. The relay is used for what? If the circuit has high power or high voltage or high current, this is going to burn the entire circuit. So they used some kind of devices. These devices are relays, just to cut the circuit when it faces some high power or faces some high current. So if the circuit has current, this kind of devices is stopping the circuit from working, not to let the circuit burn, just protect the circuit from burning, okay, due to high current. So relays are ideal for isolating high current devices such as electric motors from the PC and from sensitive electronic control circuits. Because if it is used directly with the PC, these the high current devices may be affected, like motors. If I am using the motors directly connected to the computer, maybe the motors will burn the motherboard of the computer. So relays are important. Even some of the computers, they have built-in relays used for protecting the devices or protecting the PC. Okay, you have any question in this part? You have any question about relays and switches and opto isolation, TTL? Okay, so we will take the next part, which is digital sensors for analog signals. And the first digital sensor, maybe you faced it many times when you go to the elevator, when you go to you are driving or getting into an elevator or entering a big mall. Um, Maybe you are facing this kind of digital sensors in many places you go. It's very simple. It's working is very simple. If you see, these are the magnetic fields. And as you see, there are two types of there are magnetic fields like making circles. If somebody is stopping inside the magnetic field, it will cut the magnetic field. So it makes the magnetic fields weak. So the sensor can know that there is weakness in the magnetic field and then initiate a digital output. So digital outputs means if there is nobody standing in front of the sensor, so it is logic 0. If somebody is standing inside the magnetic field, its logic will be 1. Accordingly, maybe the door will be open or the elevator door will be open. So this is some kind of switches. It contains inductive proximity switches. Inductive proximity switches, this means it has some kind of magnetic field and it senses the proximity object or the near object or the neighborhood objects and can decide that some object is passing by the switch. It produces a single bit. It produces a single bit. Either there is some object is passing by the sensor or there is no object is passing by the object. So it is binary, either 1 or 0. When exactly it output a single bit, when some kind of a change is happening, some kind of a change in some physical parameter like spatial separation or displacement rises above or falls below a predefined limit. So it's according to physical parameter, the output will be changed either to 0 or 1. The sensors of this type are known by encoders because they have a signal and this signal is encoded to a digital form. They are known as encoders. Okay, I think you have faced these type of sensors many times in our real life. Another sensor is used for speed measurement. This sensor is called rotor tachometer. Tachometer, okay? It also has a magnetic field pickups. and produce a stream of digital pulses in response to the rotation of a ferrous disk. This ferrous disk is attached to the tire of the car, for example, and a probe is used to detect the speed of the tire. Just according to magnetic field pickups. These pickups is used to measure the speed of the tire, accordingly the speed of the car. Also, the angular velocity or incremental changes in angular position can be measured with these devices. It can used it can be used for many applications like the angular velocity or acceleration, you can say. This is these kind of parameters can be measured by rotor tachometer. The pulses rate is proportional to the angular velocity of the disk. According to the velocity of the disk, there are pulses created, and the rate of these pulses represent directly the speed of the disk. Also, some kind of sensors are used for measuring linear motion. It's all about motion, it's all about velocity, it's all about speed. The rotor tachometer is used for this purpose. We have the encoder, shaft encoders is used. I think you have seen this in digital logic design. As like shaft is used, shaft encoders are used also for the rotary position and also for the knowing how the rotary position means the angle of movement, the angle of movement. And it is not using the binary encoding, but using the gray encoding. And the idea is very simple. We have a disk like that, and this disk has two sides. First, one side has photo or LED, and the other side has photosensor or photo transistor. And light when the light is passed, or when the light having or passing, or when the light sees the white place, the light passes from the LED to the phototransistor. When there is a blank place or black place, the light cannot pass. Okay, so here, for example, the gray is used for this purpose because of the error. If you see the red line here, um, we have very simple error here. This is simple error. That error, uh, that error is cancelled. Why? Because we are moving, we are changing only one bit at a time. For example, here we are changing one bit at a time. We are changing this part. But here, if you see, we are changing many bits at a time. These two bits are changing. So when we have an error here, this error will affect the measurement because the values will be changed immediately between for example, 1101 and 1111, and then returning back again to 0011. This is going to confuse the sensor, but this one will not confuse the sensor. Even we have, as you see, this is an error. This is a small error here, but this error will be cancelled because we will change only, just to change directly to the next value from 1001 to 1011 immediately. There is no change after that. There is no change after that. It will stay for this value for the period needed. Okay. So again, the shaft encoders depend on a disk, and this disk contains blank or black places and white places. And the disk contains two sensors or two components. One component are put or is put on one side of the disk, and the other component is put on the other side of the disk. The first component is lead, it's put to the left hand side of the disk, and the photo transistor is put on the right hand side of the disk. Then the lead or the how to say the light is passed from the lead to the photo transistor through these uh, white places, and is black or blocked using the black places. Accordingly, we can have digital value of the shaft, and accordingly we can measure the angle of rotation. Okay, I think we can have. Okay, you have a question in this part? No questions?
No, Doctor, no.
Okay. Okay, let's move to the sensors and transducers. So the transducer is a device that converts the physical energy or from the outside world to another form of signal, like electrical signal, and is used just to convert one physical signal from one form to another. We can say transducer is just a sensor because it takes the physical phenomenon and convert it to some kind of another physical phenomenon like electrical signal. For example, we take pressure and then convert this pressure to an electrical signal. The transducer is the sensing element that responds directly to the physical quantity to be measured and forms part of an instrumentation or control system. So if it is the case like that, we can say the transducer is the sensor. Of course, you know many types of sensors like temperature sensor, like pressure sensor, like velocity sensor, like rotations, as we have seen the angle rotation sensor, the tachometer for speed also can be used for speed measurement. So all of these are some kind of sensors that we are using daily. There are two types of two types of transducers. The first one is active transducer, and the second one is passive transducer. The active transducer is taking non-electrical signal and convert it to electrical signal. Non-electrical signal and convert it to an electrical signal. Like the thermocouples. The thermocouples is taking the temperature and convert it to electrical signal. This is active transducers. The passive transducer is just taking an electrical signal and convert it to another value, like taking resistance and for example, we have electrical signal and then we measure the we take from physical world, we take an electrical signal and we represent that electrical signal in another form. That's why it is passive. We are dealing with the same thing. But here in the active transducer, we are dealing with different things. We are dealing with non-electrical signal and then convert it to electrical signal. But here we have electrical signal already used used in the transducer, and then we convert it to another value according to the physical phenomenon that we are measuring. Okay, so this is the main difference between both of these two types. The active transducer is converting non-electrical signal to an electrical signal, but this one is using already existing electrical signal and change its value according to the physical quantity that is measured. For example, uh, the resistance, for example, or the inductance or capacitance. We will change these values according to change in the physical quantity. So it is all about changing resistance or changing inductance or changing capacitance according to the measured value. For example, we have string gauges. It is resistive change to stress. So we have stress, and this stress is a physical quantity. We will not convert the physical stress to an electrical signal because it is not active transducer, it is passive transducer. It's like converting the value, changing the value of a resistance. We will see that in this lecture, inshallah. So it's like changing the value of a resistance, not a changing or not having something in physical world called stress and then we convert that value to, no, it is not like that, but it is changing the resistance value according to the stress. So it is passive. It doesn't have another form of physical world signal. No, we have resistance, and the resistance is changing according to the physical phenomenon. And we have some characteristics for the transducers. These characteristics are accuracy, sensitivity, repeatability, and range. The accuracy is how close the measurement to the actual value of the process variable being measured. How close this value to the real value. We have real value and we have the measured value. The accuracy means the distance between these two values should be minimum. Sensitivity. Sensitivity means the amount of a change in the output signal from the transducer to a specified change in the input variable being measured. Sensitivity means what? In other words, we can say how the transducer, how much the transducer is sensitive or sensitive, how much the transducer is sensitive. Whenever we have a change in the, for example, the temperature, the change will be in the measured output. Immediately, we will have change in the measured output. So, for example, if we have a temperature and this temperature is very high, and the sensor is sensing a very high temperature, that's good. But when the temperature is suddenly changing to very low value, the sensor should be able to detect this transition immediately in real time. And the measurement, which was very high, should be changed to very low accordingly. This is sensitivity of the sensor. And repeatability. Repeatability means if I repeated the measurement many times, how close this value will be, how much the value will be close. For example, if I have a temperature and I'm measuring this temperature, it is, for example, 35. Okay, so it is 35, and I measure it again, it is 35. I measure it again, 35. But if I am measuring one time it's 35, one time it's 37, and one time it's 34, and so on, this is not good. The repeatability is not good. If I repeat the measurement, I should have the same value. This is the meaning of repeatability. I should have a transducer with good repeatability. And last thing is range. Range means the difference between the maximum value and the minimum value measured. The maximum between the, oh sorry, the value or the, yes, the value between, or the range is the value measured as the difference between the maximum value and the minimum value. This is the range of the sensor. For example, the range of weight, you can say, for cars is different from the balance used for for human. Uh, Also, the range of balance used for gold, it would be different because the weight is different in all cases. The weight of the gold is very light. The weight of human is different from the weight of cars. So the sensor or the weight sensor will be different or measure different ranges, different ranges. These are the characteristics of the transducer. Okay, do you have any question in this part? You have any question in this part? No
No,
question?
doctor, no.
Okay, can anybody tell me the difference between active and passive sensors? Active and passive sensors, anybody can tell me? The difference between active and passive sensors. And Nurhan is sharing on chat. Exactly, active is taking non-electrical signal and converted to electrical signal, but the other one is just taking value and convert this value, like capacitance, like resistance, changing its value. Okay, okay. And okay, can somebody tell me the sensitivity of a sensor? What is the meaning of sensitivity? Sensitivity of a sensor, or the meaning of sensitivity? Okay,
Accuracy يمكن دكتور ولا؟
accuracy, yes. Accuracy,
صحيح؟
no, accuracy I think is different because accuracy means if the value is true or false, or if it is near the real value or not. But sensitivity is different, little different from the accuracy. Okay, can anybody tell me the accuracy? Sorry, the sensitivity of the sensor? Okay, sensitivity means For the sensor, sensitivity means if the sensor is measuring, for example, temperature, and the temperature is changing swiftly, the output on the measurement device should be changed accordingly with the same speed. For example, if I change from high to low temperature, the measured output should be changed to from high to low too immediately. This means sensitivity. Not to have measurement after, for example, 1 minute or something is not good. The temperature is changed uh, from 1 minute ago. This is not good. Should be immediately, right now, 1 second, less than 1 second, like that. This is the sensitivity. Okay. Okay. Should we have a break for we will return back at 10 o'clock. Okay.
اوكي
We'll
دكتور
return
اوكي.
back. Okay,
ان
inshallah.
شاء الله.
We'll return back at 10 o'clock, inshallah. So we continue the lecture. We have described the transducers, the sensors, different types of switches, and the opto isolation. And we talk about the characteristics of sensors. Today, or the next lecture, or the next part of the lecture, we will describe the weight stone bridges. The weight stone bridges. Because the Wheatstone bridges is the basic component of any sensor, of most of the sensors uh, used to measure even very small voltage change, or very small value change. The concept of Wheatstone bridge is, as you see it on the right hand side, we have four resistance four resistances connected, two of them connected in serial and another two connected in serial, and these two serial connected together with that two in parallel. So it's like having this kind of bridge using these two serial. R1 and R2 are serial, and R4 and R3 are serial. But this branch and that branch, they are parallel. This is the main concept of it. I will tell you how it is working. The Wheatstone bridge, it is used for measuring small changes in electrical resistance. You can say this is the input value, the input voltage, and this is the measured voltage here. The measured voltage is here. Okay. The most important feature of the Wheatstone bridge, it can be used to measure even very low values of resistances down in milliohms. Even milliohms can be measured using this Wheatstone bridges. To understand how Wheatstone bridges, or the idea behind the Wheatstone bridge, we have to revise some basic concepts from circuits, from digital circuits. The concept is called the voltage divider network. So if we have here, this is the ground terminal, and this is Vn, and we have two serial or two series resistances, R1 and R2, and the voltage between Vn and V0 is Vn, just Vn, and this Vn will be distributed evenly on both R1 and R2, and the voltage will be changed according to the value of R1 and R2. For example, if R1 is greater than R2, so the voltage on R1 will be higher than the voltage on R2. If R2 is bigger than R1, so the voltage on R2 is bigger than the voltage on R1. Is there a kind of formula to measure the voltage on the resistance? Yes, this is the formula. We have Vn here, and we have the percentage of R2 corresponding to both of them is like percentage of R2 to the total values of resistances. It is R2 over R1 plus R2. R2 over R1 plus R2. It giving the percentage of the input according to the value of the resistance. Now, so if we have resistance R2 is bigger than R1, this means we will have voltage drop on R2 bigger than voltage drop on R1. And if R2 is small, this means the voltage drop on R2 will be smaller than the voltage drop on R1. And this is the formula to calculate the output, the V output, which is here. The V output is R2 over R1 plus R2 multiplied by the Vn. What about this circuit? This circuit has 4 resistance in serial. R1 with 10 ohms, R2 with 20 ohms, R3 with 30 ohms, and R4 with 40 ohms. We wanted to have or to measure the voltage drop between A and B. How can we calculate it? Anybody knows? Anybody knows how the idea behind how to calculate the voltage drop on AB? The difference or the voltage difference between AB. The idea, you tell me the idea. Anybody knows? We have here the voltage source with 10 volts, and we want to know the voltage on AB. How to calculate it? Okay, no, nobody knows. Okay, the idea is very simple. The idea is just to know the percentage of this value corresponding to the total values of all resistances. How to do that? It's just to divide R3 by the total values of resistances. It's like dividing 30 by all of these together. Dividing 30 over 10 plus 20 plus 30 plus 40. 30 over 10 plus 20 plus 30 plus 40. This is giving us the percentage or the contribution of R3 to the total resistance, to the total resistances, to the total value of resistance, okay? And accordingly, we multiply this percentage by the input voltage. We multiply by the input voltage, which is 10. So we multiply 10 by 30 over 10 plus 20 plus 30 plus 40, and this will give us 10 by 0.3, which is 3 volts. So R3 is taken from the voltage source 3 voltages. Of course, you can guess it because it is like 30 will give 30 percentage of the voltage, 20 will take 20 percentage of the voltage, and 10 will take 10 percentage of the voltage. This means the voltage here, let me draw it. The voltage here will be, we calculate it as 3 voltage. And here will be 4 voltage, 4V, and here will be 2 because this is 20 over 1. This is how much? 10. Yeah, it's over 100. So 20 over 100. So this means 2 over 10, which is 20 percentage. This is give us 2 voltage. And this is because this is 10, this is 1 voltage. So if we sum up all of them, 1 plus 2 plus 3 plus 4, this is 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, which is the voltage source. According to which value here, we will take the corresponding voltage. If the resistance is high, it will take more voltage drop. If the resistance is low, it will take low resistance or low voltage drop. So to understand the Wheatstone bridge, just understand how to calculate the voltage here. If you don't understand, you tell me to repeat it. Okay, you understand? You understand how to calculate the voltage? Any question? The voltage is very easy. Just, according to the value of resistance, we will take more voltage because the value of resistance is high, so it will take more voltage from the voltage source. Okay, this is the idea. Okay, now we are going to use the voltage divider network to reach the Wheatstone bridge. Now we have 2 branches here. If I want to calculate the voltage drop at C, this is very easy. We will take it as 20 over 20 plus 10, which is 20 over 30, which is 1/3 of 12, which is 4 volts. So C will be 4 volts, 4 voltage. Why it is saying 8 voltages? Okay, let me calculate it. I will change it if it is not true. This is 10. Yeah, it should be. Okay, this is the voltage here is 10 over 20 plus 10, which is 1 over 3 by 12, and this is going to give us 4, right? So this is not 8. I will fix it. This is not 8. It should be 4, not 8. Let me. But what about this one? This is 8. Why? This is 12. Okay. Okay, let's take this one. 10. This is 20 over. Okay, sorry. This is 20 over 20 plus 10. I'm calculating the voltage here. It is 20 over 10 plus 20 multiplied by 12. If this 8, yes, should be 8 because 2 over 3, 2/3 of 12. This is, yes, this is 4. This is the total is 8. Okay, it's not error. I just confused because we have 10 and 20. So for 20 it will be 8 voltage, as he said exactly. It is 8 voltage, and for D also it is 8 voltage. But if, okay, let me clean it up. Okay, now we know that the voltage at C is 8 and the voltage at D is also 8. Just because we know this is parallel circuit and the voltage applied on parallel branches are the same, is the same. So we have here C voltage, the difference between C and B will be 8 voltages, and the difference between D and B will be also 8 voltages. What is the difference between the voltages at C and D? The difference between C and D, do you know? Anybody knows? The difference, the voltage difference between C and D. Anybody there? حد عارف الفرق ما بين C and D؟ الفولتج يعني الفرق الجهد ما بين C و D هيطلع كام؟ هنا الجهد بيساوي 8 وهنا الجهد بيساوي 8. الفرق ما بين C و D يبقى كام؟
4 دكتور.
لا حاول تاني، محاولة أخرى. ها؟ زيرو. الياس بيقول زيرو، صح زيرو، لأن هنا 8 وهنا 8 يبقى الفرق زيرو. موضوع بسيط يعني. تمام. فيعني عندنا هنا الفرق زيرو ما بين السي والدي، الفرق بيكون زيرو لأن المقاومة اللي تحت بتساوي 20 واللي تحت برضه هنا بتساوي 20 واللي فوق بتساوي 10 واللي فوق بتساوي 10. لو احنا عملنا سويتش بقى، يعني خدنا البرانش ده سيبناه زي ما هو وبعدين عملنا سويتش، يعني بدلنا مكان الريزيستنس، خلينا ال20 تطلع فوق وال10 تنزل تحت زي الصورة اللي تحت دي. وبعدين قسنا الجهد هنا وجهد هنا هنلاقيه مختلف لأن المقاومة اختلفت. فالجهد اللي هنا هيبقى 8 عشان المقاومة هنا 20 زي اللي فوق بالظبط، والجهد اللي هنا هيبقى 4 عشان المقاومة هنا 10، فالجهد هنا هيختلف. طيب سؤال بقى، الفرق ما بين سي ودي هيطلع كام هنا؟
4 دكتور.
هيطلع 4. ممتاز. يبقى فرق الجهد ما بين سي ودي في الحالة دي هيبقى كام؟ هيبقى 4. يبقى أنا ممكن أعمل إيه؟ الدايرة اللي فوق دي بيسموها الدايرة المتزنة، البالانسد، يعني دايرة متزنة. ليه؟ لأن الفرق ما بين السي والدي بيساوي 0. الدايرة اللي تحت دي مش متزنة لأن الفرق ما بين السي والدي بيساوي 4 أو ما بيساويش 0، ممكن يبقى أي فاليو تاني. فأنا ممكن الفكرة إيه عندي في الويت ستون بريدج دي؟ إن أنا أقعد ألعب في المقاومات اللي فوق واللي تحت دي، أو أغير في أي مقاومة. R4 عادة بيغيروا فيها بحيث إن إحنا نخلي الفرق ده بيساوي 0. ولو الفرق ده بيساوي 0، لو جبت سنسور على اي مقاومه من دول واتغيرت، ابقى عارف قيمه الفاليو من خلال قياس الفاليو بتاعه الفولتج اللي هنا. يعني ايه؟ عارفين كده لما تقفوا على الميزان، اما تيجوا تقفوا على الميزان بتلاقي الميزان عامل 1 و2 كيلو، فانت عايز تعرف ميزانك الحقيقي بتصفره الاول. فهنا الدايره دي هتبقى صفر الاول، لازم اصفرها الاول. اصفرها ازاي؟ اقعد اغير في المقاومات دي، اقعد العب في المقاومات دي لحد ما اخلي الفرق هنا 0. ولما الفرق 0 اروح بقى ايه؟ اخلي المقاومه دي تتعرض لاي حاجه، لضغط، لاي حاجه، فقيمتها تتغير. لما قيمتها تتغير الفرق هنا هيتغير، فاقدر اقيسه على طول. اعرف ان يعني مثلا لو فرضنا ان المقاومه دي هتتغير بناء على الضغط، يعني مثلا او درجه الحراره مثلا. لو المقاومه دي هتتغير بناء على درجه الحراره وانا مظبط دي انها بالانسد يعني 0، فالتغيير هنا هيخلي فيه فولت هنا. تغيير درجة الحرارة على المقاومة دي هيغير المقاومة دي وهيخلي فرق الجهد ده مش زيرو، هيطلع فاليو تانية. الفاليو التانية دي هتبقى مساوية لدرجة الحرارة اللي هنا. يبقى أنا كده قست درجة الحرارة. تاني يا جماعة، لو ما فهمتوش دي، لو ما فهمتوش الويت ستون بريدج دي، مش هتعرفوا تفهموا أي سنسور موجود. الفكرة بسيطة ولكن هي فكرة فعالة. احنا عندنا، عشان كده انا بقولها بالعربي، يعني انا لو ما فهمتوش دي، يعني ده المحتوى الرئيسي عندي بالنسبه لمحاضره النهارده، الويت ستون بريدج دي. عندنا مقاومات زي ما قلنا في الشبكه، اللي هي الفولتج ديفايدر نتورك دي، اللي هي ازاي نقسم الفولتج على المقاومات. وعرفنا ان كل ما المقاومه بتزيد كل ما بتاخد فولتج اكتر. ف الأول كنا بنقول إن في برانش فيه 10 و20، وفي برانش تاني فيه 10 و20. لو خليناهم بالشكل ده هنلاقي الفرق ما بين الجهد ده والجهد ده بيساوي زيرو. ولكن لو عكسنا بقى الاتجاه، لو قلبنا اللي تحت فوق واللي فوق تحت في البرانش اللي على اليمين ده، هيطلع فاليو. طب أنا بعمل حكاية السويتش دي ليه؟ ما أقعد أشتغل على دي على طول، لا، أنا بقلب السويتش ده عشان بهدف ان انا اقدر اقيس فولتج ما بين الزيرو وما بين الاربعه، اللي هو الفرق ده. يبقى انا عندي رينج معين، يبقى السنسور ده عنده رينج من زيرو لاربعه. هنا المينيمم بتاعه هيبقى زيرو، اللي هو الفرق ما بين الاثنين دول هيبقى زيرو، وهنا الماكسيمم هيبقى اربعه، الجهد هيطلع اربعه. يبقى انا عندي السنسور ده يقدر يجيب رينج معين من الفولتج. الفكره ايه عندي؟ ان انا اقعد العب في المقاومات دي لحد ما اخلي الفرق ما بين الاثنين دول بيساوي زيرو. خلاص انا كده ستيبل، ظبطت الميزان على الزيرو، صفرت الميزان خليته زيرو. بعدين بقى مثلا لو انا مثلا بقيس درجه الحراره، فانتوا عارفين كل ما درجه الحراره بتزيد كل ما المقاومه بتزيد. فانا لو سخنت المقاومه دي، انا خدوا بالكم ان انا هنا زيرو يعني هنا لو حطيت الافوميتر على الطرفين ده اهو هيطلع صفر، خلاص انا كده زيرو. بعدين رحت معرض دي للحراره، فالمقاومه دي اتغيرت، زادت قلت ماليش دعوه بقى، المهم انها اتغيرت. زادت او قلت المقاومه دي، لو زادت ولا قلت الفولتج اللي هنا اكيد هيتغير، انتوا عارفين الكلام ده. لان طالما انا كنت مظبطها على ان المقاومه دي او الفولتج ده يطلع زيرو، لما دي اتغيرت اكيد الفولتج اللي هنا هيتغير، اكيد الافوميتر هيطلع فاليو جديده. يبقى معنى كده ان انا قدرت اهو بفيزيكال فينومينا، يعني قيمه فيزيائيه زي درجه الحراره، ترجمتها لفولتج. هو ده السنسور، هو ده فكره السنسور. طيب so the idea is just to change one of the resistance, like R3 here is as you see, this is the signal of a resistance or changing resistance. I can control the value of R3. And Rx or R4, this is Rx or R4, can be calculated by this, can be calculated by this equation. Why we want to calculate Rx? If we want to balance this Wheatstone bridge, I want to balance it. Balance it means to get the voltage, output voltage to be zero. I want it to be zero. What to do? Just to change Rx to the amount that I need. How to do that? We know that RC can be calculated by RC is calculated by R2 over R1 plus R2, and RD is calculated by Rx over R3 3 plus Rx or R4. And we know that we wanted to have VC equal VD. I wanted to have VC equal VD or RD equal RC. We want this resistance to be equal. Why? Because if the resistance are equal, the corresponding voltage will be equal. And that's what we needed. Then we can equalize this equation and multiply the two terminals. R2 is multiplied by R3 and R4 like that. And R4 is multiplied by R1 plus R2 like that. And then we distribute R2 over R3 and R4. And also here we distribute R4 over R1 and R2. Then we have two components equal here, cancelled together on the right hand side and left hand side. Then we have R2 multiplied by R3 equal R1 multiplied by R4. This means R4 is R2 multiplied by R3 over R1. R2 multiplied by R3 over R1. This is the way to balance the Wheatstone bridge. Balancing it is important, as I told you. If you stand on the balance and you want to measure your weight, you have to zero the balance first before starting measuring. We do that using this equation. Now we have an example here. This example is used for the balancing of the Wheatstone bridge. You have a Wheatstone bridge here. This R1 is 80, R2 is 120 ohms, R3 is 480 ohms, and R4 is 160 ohms. And calculate the output voltage across points C and D. We want to calculate V out. I want to calculate V out. And the value of R2 required to balance the bridge circuit. I want the value of R2. If I change it, what value will be to make C, the difference between C and D, equal 0? So the first thing is to calculate the difference between the voltage in C and D. I want the amount of V out. How to calculate it is just to have, we have here voltage source of 100, and I multiply this 100 by this resistance. Not this resistance equal exactly, but the percentage of this resistance regarding the entire branch. We have 120 over 120 plus 80. So VC will be equal to 120 over 20, over 80 plus 120, all of them. This is the percentage of 120 resistance. So it is multiplied by 100 just to get the percentage. Multiplied by 100 because the voltage source is 100. So the result will be 60 voltage. This is how to calculate VC. What about VD? VD is also the same. It is 160 over 480 plus 160, which is this one, 160 over 480 plus 160, and multiplied by the voltage source, which is 100, to get 25. The difference between VC and VD is V out, VC minus VD, which is 60 minus 25, 60 minus 25, which is 35 volts. Now I have the value of C, the difference between C and D, which is not 0 now, it is 35. I want it to be 0. If I want it to be 0, what will I do? I will change R4. But what is the value needed for R4 to balance the Wheatstone bridge? It is easy. We're using the previous relationship here. Sorry. the previous relationship here R4 is equal to R2 multiplied by R3, sorry, R2 multiplied by R3 over R1, yes. So R4 is equal to R2 multiplied by R3 over R1. Yes, you can say, okay, it's not to be confused. It's like R2 here. Yes, R4 is equal to these together multiplied over R1, like that. Not to confuse, just these together multiply them and divide by R1. So R4 is equal to 120 multiplied by 480 divided by 80. The result will be 720 ohms. What is the 720 ohms? Is the value of R2 to make the difference between the difference between the voltage difference between C and D equals 0. Okay, okay. Okay, I want to ask you some question about the Wheatstone bridge. Please concentrate with me. Please concentrate with me. The Wheatstone bridge is important in all the measurements, in all the, you can say, the sensors and transducers. The idea is very simple, but it is effective. Okay. Can anybody tell me why the voltage value here is 4? Why it is 4? How it is calculated? Why the voltage value here is 4? Why it is 4? From which place I get 4? شباب بنات. Nurhan, you are saying I'm using R3 and R4, but I want to know how to calculate it. How to calculate it? How to calculate the 4? How we get 4? Why is 4?
Because the other branch will take 8 voltage, so the total voltage will be 8 plus 4, it will be 12 voltage.
Again, please.
Because we have 12 voltage, right? So when we measure the current in
Yes.
each branch, it will be, we have 10 ohm at 20 ohm. Okay.
Yes.
So the first one will take to remove the 8 voltage, the second branch will take 4 voltage. But don't have calculator now. It can measure in using the voltage the
يعني,
beats of IR.
yes. Oh. You are saying that 4 plus 8 is 12, like that?
Sorry, doctor.
You are saying that you are saying that the voltage source is 12. So 4 plus 8 is 12, like that?
No, doctor. No. It's divided to. We can, doctor. We measured by using the equation V equals RI, IR. Sorry.
Yes. V
Sorry.
equal IR. Okay.
Yes. So I measured by using calculator, doctor, but I don't have. So it will be the first branch will take 8 voltage. Just the second branch will take 4 volt because they are parallel. So it will be the voltage will be divided.
It makes sense. It makes sense. But here we don't have how to calculate current. We should be able to calculate current beforehand. So this is long
Yes,
distance.
doctor, we have to calculate it.
No. That's why not to, we don't have to calculate current exactly.
Doctor, we can use the mesh or the.
Yes, we have a method here. We have said that we can distribute the voltage on the branches. The voltage not
But doctor, excuse me, doctor, in parallel, the voltage should be the same, not different.
yeah, but okay, but here the
You
voltage
mean in the point or in
no
the
no no ده يعني لو احنا بنتكلم على النقطة من A ل B لازم يكونوا ده same عشان هم parallel، لكن من هنا جوه البرانش نفسه اكيد مش ده same طبعا عشان لكن المجموع بتاع الاثنين لازم يكون 12. معايا زكريا؟
yes.
لكن عند النقطة دي وعند النقطة دي دول مش بارل أصلا، يعني دول مش بارل، ده عشان قصاد بعض بس، يعني ده اللوكيشن بس، مش لكن ده بارل، يعني البرانش ده والبرانش ده الاثنين كاملين بارل. تمام. فالفولتج هنا من أول A لحد B على البرانش ده هو اللي على البرانش ده، لكن من هنا لهنا طبعا هيختلف على حسب الريزيستنس اللي هنا دي. الفولتج هنا في النقطة دي هيختلف على حسب الريزيستنس دي. طبعا لازم الاثنين مع بعض يدوا 12 في الاول وفي الاخر، لازم الاثنين مع بعض لازم يدوا 12. تمام. لكن مش كده، مش يعني مش ماشيه بارل، ده ماشيه سيريال. يعني الفولتج ال 12 دي ال 10 هيبقى ليها مساهمه من ال 12، جزء من ال 12، وال 20 هيبقى لها جزء من ال 12. وهنا برضو نفس الحكايه، ال 20 هيبقى لها جزء من ال 12 وال 10 هيبقى لها جزء من ال 12. ال10 هنا صغيرة فالفولتج هيكون صغير، وال20 هنا كبيرة فالفولتج هنا هيكون كبير. تمام. هي هنا الأربعة والثمانية لو لاحظتوا إن هي بتساوي 12، بس دي جاية ليه؟ لأن الفاليو هنا مش عشان إن الفولتج بيتحسب كده إن ال 12 بتساوي 4 زي الثمانية، لا طبعا. لكن اللي حصل إن ال10 وال20 اتقلبوا، خلوا ال20 فوق وال10 تحت. لكن لو الفاليوز اختلفت اكيد مش هيبقى ليه علاقه بال 12 دي خالص، يعني الفاليوز اللي هنا مش هتبقى ليها علاقه بال 12، لان هنا اللي مخليهم ليهم علاقه ان اصلا ال10 اللي هنا وال20 اتقلبوا بقوا 10 تحت وال20 فوق. فالفولتج يعني اصلا من غير ما تقلب دلوقتي الفولتج اللي هو ال 12 ده ال20 واخده منه 8 وال10 واخده منه 4، فلما اقلب العكس هيبقى موجود، الاربعه هتبقى تحت والثمانيه هتبقى فوق. عشان كده تلاحظ ان الثمانيه والاربعه بيساوي 12، لكن مش في كل الاحوال ان ال 12 دي هتساوي مجموع الاثنين دول، طبعا لا. هي هنا جايه بالصدفه ليه؟ عشان المقاومه اللي فوق واللي تحت شبه بعض. برضو انا ما عرفتش السؤال، ما فيش حد جاوبني على السؤال ازاي احسب الاربعه دي اتحسبت ازاي.
Doctor, it's very simple. You just create voltage, calculate voltage at point C and point D and subtract them because they're different potential difference. Or you can use the divider rule also.
Doctor, we can use if we
ثواني هرد على كلام زكريا الاول. لا، انا عايز الفولتج هنا على العشرة دي، من دي لحد بي، مش الفرق ما بين الاثنين، لا انا عايز دي اللي هو على العشرة. الفولتج من دي لحد بي، الفولتج ديفرنس اتحسب ازاي؟
It's 4 minus 0 because it's grounded.
لا انت مش فاهمني، انا هقول لكم على حاجه، شكلكم كده ايه، في حته كده انا عاملها دي مش محسوبه، انا ما اعرفش هي كام، يعني الكلام ده مش محسوب. انا عايز اعرف بقى دي الاربعه جت منين، يعني الاربعه اللي هنا دي اللي كانت موجوده من شويه اللي انا مسحتها دي اتحسبت ازاي؟ م.
Doctor, there are many ways like divider rule or
طيب
loop or
ماشي اتفضل، يعني قول اي حاجه. زكريا معايا، اتفضل. يعني
we
قول
can
we
اي
make a
طريقه. ها.
we
equation
can't
first.
just divide like because we have voltage equals I times R, so we have I and we multiply it by R, we
طب
get
اي
the
بتساوي
voltage.
كام؟ الاي 2 لازم
We
نعرف
can
الاي
make
2.
equation for this. We have two nodes, so we have two equations. and after that we solve it.
انت قصدك يعني هنعمل equation فيها متغيرين وبعدين
Yes.
اوكي. طيب دي طريقة يعني هي لونج واي يعني، لكن جميلة، طريقة حلوة، ودي اكيد اللي انتوا درستوها في السيركتس يعني، ان انت بتجيب الكرنت وبعد كده بتحل باستخدام الايكويشنز بتاعت الكرنت. طيب الطريقة بتاعت
لوب دكتور، لوب اور مش كان يوز.
لا يعني انا مش عارف تقصد ايه بالطريقة دي، لكن الطريقة الاسهل ان انت تجيب، الطريقة الاسهل اللي احنا بنستخدمها هنا ان انت تجيب نسبة العشرة دي من المقاومة الإجمالية بتاع
ده
البرانش.
1/3 دكتور، 1/3
بالظبط بالظبط
مضروبة
يا
في
خالد،
12، مضروبة في 12 يطلع 4 صح.
بالظبط كده، تمام كده انت جبت الإجابة الصحيحة 100%، اللي هو ان احنا نجيب الكونتريبيوشن بتاع الار 2 الار 4 بالنسبة للبرانش كله. الكونتريبيوشن هو 10 على 20 زائد 10 اللي هي 1 على 3 اللي هي تلت، تلت مضروبة في 12 يدي 4، فعشان كده الدي هنا 3 4. نيجي لهنا السي هنا الكونتريبيوشن بتاع ال 20 بالنسبة
2/3
للإجمالي بالظبط 2 على 3،
ضرب
2 على
12
3 لو ضربتها في 12 هيطلع
3.
8. تمام ممتاز، شكرا يا شباب، شكرا على مساهماتكم، ما شاء الله عليكم، يعني حاجة جميلة. طيب خلينا نشوف والله. اوكي طيب ايه فكرة السنسور؟ حد عارف يعني؟ لو انا دلوقتي انا يهمني ان انتوا تعرفوا المعلومة قبل ما يكون احنا يعني حابب ان انا استوضح منكم كل حاجة عشان اتاكد ان انتوا عارفين المعلومة ولا مش عارفين المعلومة دي. يعني بالنسبة لي لو طلعتوا بالويت ستون بريدج وفاهمينها كويس دي كويس قوي بالنسبة لمحاضرة النهاردة. فانا دلوقتي عايز اعرف ايه فكرة ان انا استخدم سنسور في البريدج دي، ايه فايدتها بالنسبة للسنسورز، ليه بندرسها وليه فايدتها بالنسبه يعني بنعمل بيها ايه بالنسبه للسنسورز. هشوف بس التشات لان في ناس بتكتب على التشات. آه نورهان كانت بتجاوب، كانت مجاوبه اجابه صحيحه على التشات فعلا. يعني قالت الطريقه 10 على 20 زائد 10 بتساوي تلت، تلت في 12 بيساوي 4، مظبوط. تمام تمام يا نورهان، اجابتك صحيحه. طيب عايزين بقى نعرف بقى الناس الشاطرة الممتازين المتميزين يقولوا لنا ازاي البريدج دي بنستخدمها في السنسنج. نستخدمها في السنسنج ازاي؟ عايزين نقيس مثلا التغير في المقاومة بناء على التغير في درجة الحرارة، ازاي هستخدمه؟ استخدم البريدج دي في انها تكون سنسور، ازاي بقى؟ ايه الفكرة؟
again دكتور.
ها اقول لك تاني.
again yes yes دكتور.
اوكي اقول بالعربي وبعدين بالانجلش، خلينا
ما
نقول
في مشكلة دكتور، بس ما كنا سامعين الصوت،
اه
كان الصوت مو واضح دكتور.
طيب البريدج دي اللي هي الويت ستون بريدج، ازاي نستخدمها في السنسنج؟ ازاي نستخدمها كسنسور؟ ايه الفكرة بتاعتها كسنسور؟ ازاي نحطها جوه سنسور او نستخدمها جوه السنسور؟
Doctor, maybe of the unknown measurement of the resistance, because we have one leg that doesn't have resistance, so we put that as like the outer side sensor, and like the unknown
بعدين
resistance, and it takes the unknown resistance and it has a certain calculation.
اوكي ده فعلا ده السنسنج بشكل عام، لكن ايه علاقته بالبريدج دي؟ What the relationship between the sensing and this bridge? You're talking about how to sense physical value, how to sense it, but how to use this bridge in sensing. the idea. I know that the difference between these, I can control the difference between these two terminals, because I have two types. We have the balanced one and the unbalanced one. The balanced one is having the difference between C and D is equal to 0, and the unbalanced one is the opposite of or making the R3 and R4 opposite in the location. Accordingly, we have another value which is 4. So I can control the voltage between these two terminals. I can have the value from 0 to 4, any value. I can control it just by changing the resistance here. Anyone, but actually we are changing resistance R4 according to physical phenomena. So the idea is what? The idea is what? Do you know? The idea of having
Doctor,
to measure electrical.
maybe for like the bridge is unbalanced because there is one leg that is missing. So the idea is
there is no
like
leg
to
missing.
find.
Okay, no, there is no leg missing. They are all there. But here, this is just saying this is attached to a sensor, and this is only the resistance can be changed, can be controlled. There is no missing value here. They are all there. But I mean the idea behind measuring the physical phenomenon using this Wheatstone bridge. Okay.
Doctor, also
Here.
maybe because when the resistance change, the sensor will have like the output or something.
Yes, exactly. But the idea يعني I mean for example، يعني انت قلت كلامك صح 100% زكريا، كلامك مظبوط 100%، بس انا عايز اعكس ده على البريدج دي، على البريدج اللي قدامي دي. انت ما بيحصل if you change the physical value the voltage will be changed. That's exactly the sensing. But how to control this value using this Wheatstone bridge? Okay. Yes, it is very simple. دلوقتي احنا ممكن نتحكم في الفاليو بتاع الفولتج ما بين السي والدي، صح ولا لا؟ ممكن نتحكم فيه ولا لا؟ ممكن نتحكم فيه. قلنا ان احنا ممكن نغير المقاومات دي. فاول حاجه هنعملها ان احنا نصفر الفرق ما بين السي والدي، نخليه 0. ودي سهله، احنا قلنا يعني مثلا انا عايز اصفر الجهد ما بين السي والدي في الدايره دي بالارقام دي. قلنا ان احنا نخلي المقاومه ده اهي بتساوي 720. ده الحل. عشان اخلي الجهد ما بين السي والدي اللي هو اصلا بيساوي 35، دلوقتي بعد الحسابات طلع 35، عايز اصفره اخليه بيساوي 0، يبقى لازم اغير المقاومه دي واخليها 720. طب ليه بصفره؟ ليه بصفره؟ ليه
عشان
بخليه؟
بالانس دكتور.
عشان اخليه بالانس بالظبط، عشان اخلي البريدج دي بالانسد. يعني انا بخلي ده 720 عشان زي ما انت قلت بالظبط اخلي السيركت دي او البريدج دي بالانسد. يعني ايه؟ يعني الفرق ما بين السي والدي بيساوي 0. يعني ببساطه كده لما تقف على الميزان وتلاقي الميزان مدي 1 أو 2، فانت بتعمل ايه؟ بتصفره الاول. لو انت بتروح المول وتلاقي الراجل بتاع الفاكهه بيوزن، فتلاقي الميزان مش جايب 0، فبيعمل ايه؟ بيصفره الاول قدام عينيك، وبعدين يبدا حتى بتوع الذهب وبتوع الفاكهه فبيصفروا الاول. فاحنا بنصفر الاول الايه؟ البريدج بتاعتنا دي، الميزان بتاع ده بنصفره الاول. ليه؟ عشان لو حصل تغيير في اي مقاومه من المقاومات دي بناء على درجه حراره او بناء على ضغط او بناء على بريشر، على طول ينعكس على الفولتج ده، هيطلع قيم للفولتج ده. هي دي الفكره. هو ده اللي انا عايزه، يعني عايزك تقوله لما اسالك واقول لك ايه الفكره في الويتستون بريدج، هتقول لي ان عندي في فرق جهد ما بين السي والدي. الفرق الجهد ده مش بيبقى 0، فانا لازم اخليه 0 الاول. اصفره، اقعد اغير في المقاومات دي لحد ما اصفره. بعد ما يبقى زيرو، اي تغيير في المقاومات اللي موجوده هنا بناء على تغير فيزيائي هينعكس على طول على الفولتج ده، لان ده مش هيبقى زيرو بقى بعد كده، هيطلع فاليو. الفاليو دي قايسها بالافوميتر، هي دي الفاليو بتاعت الايه الفيزيكال فاليو. يعني مثلا لو درجه حراره، يبقى الفاليو اللي هتطلع هنا، الفولتج اللي هيطلع هنا هو ده درجه الحراره. لو دي مثلا بريشر، طبعا لو هو لينير، لو فرضنا ان هو لينير، يعني في لينير ريليشن شيب، فدرجه الحراره اللي هنا هتنعكس على الفولتج اللي هنا، بريشر اللي هنا هينعكس على الفولتج اللي هنا. تمام. طيب، تاكيدا ان انتوا فهمتم، حد يقدر يقول لي الفكره تاني؟ هم؟
Doctor,
يعني
you mean the idea of how to say how the Wheatstone bridge work?
yes, in sensing, not the
Uh,
Wheatstone bridge, in sensing.
Yes. Basically, you said that the V out voltage between or the potential difference between point C and D
Yes,
should be zero,
yes,
and that can be occurred by like playing out with the resistances until they become zero.
yes,
That yields to when there is like an outer signal or an outer sense of physical phenomena, it can be changed for the voltage to detect to
yes,
detect the input.
exactly. Yes, that's exactly. Yeah, exactly. So we have we are balancing the Wheatstone bridge first. We have the difference between C and D equals zero. Now we can change, or if the any of the resistance is affected by physical phenomenon or physical measurement, it will be reflected directly on the avometer, or the value here will be different than zero, or higher or lower than zero. Then this reflects exactly the physical measurement. Okay. Okay, that's enough for Wheatstone bridge, and then we move to the temperature sensors. This is the last part of the lecture. The temperature sensors, you have two common sensors here, the thermocouple and the RTD. We have two of them. This is the advantage of this one is it is self-powered and it is inexpensive, and it can measure a wide range of temperature values. And the disadvantage of this one, it has low output voltage and it needs some reference. I will tell you about the reference in the upcoming slides. And the range between minus 270 to plus 2000. This range is very high. This is good. This is, you can say this is something good about the thermocouple. But the RTD is stable and accurate compared to the thermocouple. It is most stable and most accurate, and also inexpensive. It is, you will say, it is dependent entirely on Wheatstone bridges for resistance, and it is not expensive, but the range is not high. The range is 200 to minus 200 to plus 800. Okay, and also it needs some external some external current. Okay, give me a second. I have give me a second. I have a phone call. Just a few seconds. These the two temperature sensors that we are going to study, the thermocouple and the RTD. The thermocouples. The thermocouple is very straightforward. We have two different metals, the metal one in red color and metal two in blue color. And if we heat it up, the two metals, there is a difference between, there will be a difference in voltage between the two metals after heating them, because each metal is is affected by the heat in different ways. So for example, here, if you see, we have metal A and metal B, and this is the temperature, and we measure the voltage according to the difference between the voltage between metal A and metal B. You can see that the voltage is equal to S multiplied by delta T. So what is S? The most important feature here is S. We can say Seebeck temp coefficient. What is the Seebeck temp coefficient? Is that the coefficient of the metal. The metal, each metal, you can say it is a parameter for the metal. This is metal A and metal B, they are different. And this coefficient is standard. For each metal, they have different S. For example, if you see this table, you will find, you can see that we have different types of alloys, and the coefficient is different from one to another. For example, in the iron constant, we have 51, and for the platinum rhodium, we have 7. So they are totally different. So you see, this value is very low and this value is very high. So that for each metal, we have different S, and the delta T is just the real difference between the temperature at metal A and metal B. Okay, this is the idea of of the temperature sensor or the thermocouple. We have here a problem because the temperature will be different according to the temperature of the home temperature, or the home temperature, or the, how to say, the room temperature, the room temperature. This is going to be a problem because we need to have temperature equal to 0, because if we don't have temperature equal to 0, the metals will be affected by that temperature. How to solve this problem? We can solve it by having a reference ice box like that, just to give the metal the chance to be zero at zero temperature. But this is just a lab setup. It cannot be used uh, for practical use. It is not practical. We cannot have this at places that we want to measure the temperature, because it is not feasible to carry ice box whenever you want to carry whenever you want to measure temperature. There is another solution for this. This is electronic ice points. The electronic ice points is an electronic device. It can sense the temperature and make the temperature 0 at metal A and metal B. And this is more feasible and more portable. You can use it whenever you want, and it reference the temperature to 0. That's why we need it to be more accurate. We need this type of um, the ice boxes, we can say, just to make the accuracy, or to make accurate measurement of the temperature. What about the RTD? The RTD is, you can see it's like that, one of the shapes here. This rod is uh, exposed to the temperature, and the measurement is passing to an electrical device. This is the shape of it. But how it is working? It is working by this, sorry, this part. I don't want you to keep it or to recite it. يعني انا مش عايزكم تحفظوا الشكل ده، احفظ بس الشكل العام ليه بس. مش عايزك تحفظ كل القطع دي فقط. You don't have to recite it or keep it, or no, just to see the shape of the RTD in a physical world. يعني it is used like that. This is the shape of it. If you want to buy it, you will find it like that. But internally, the idea which is important for us as engineers is to understand how it is working. We know about Wheatstone bridge. We have the Wheatstone bridge here. The RTD is sensing the temperature using this value. First, we need to balance the Wheatstone bridge to 0. So the value between the voltage value between X and Y will be 0. Then according to the temperature here, as you know, this is well known that the temperature increase, this means the resistance is increase. Temperature increase means resistance increase. So this resistance is exposed to temperature, and accordingly this resistance will be increased in value, and accordingly the voltage will be changed. Because it is 0, now it will be different. Accordingly, we have the value of the temperature, or the temperature value. Okay, it's very simple. If you understand Wheatstone bridge, that's why I concentrate on Wheatstone bridge many times, just to let you understand how to how it is working. So RTD is mainly Wheatstone bridge based. Okay. Okay, that's all for today. If you have any question.
يعطيك العافية دكتور.
جزاك الله خير دكتور، ما عندك سؤال.
شكرا. ثواني تحضير فقط. عبد الرحمن عمر صالح.
نعم دكتور.
اوكي. سعيد احمد.
نعم دكتور، موجود سعيد أحمد.
اوكي.
دكتور عبد الرحمن حميد موجود، اسمه موجود هنا.
عبد الرحمن حميد موجود.
موجود، اسمه هنا موجود.
ايوه موجود. اوكي موجود على اوكي ماشي. اوكي هو موجود بس بالاسم، لكن بالجسم مفيش. بالاسم مش بالجسم. طيب دعاء موجودة. أحمد النمروتي مش موجود برضو. امال مين اللي موجود بقى ان شاء الله؟ اوكي. الياس يحيى موجود. تمام. عبد اللطيف محمد او اوكي
موجود.
اوكي. علاء احمد.
يا دكتور موجود.
تمام. محمد حسين. محمد حسين.